thank you for attending today's webinar. We're talking about how to use Linux for wireless learning analysis and more. And we're doing something a little bigger for you with this. Today is going to be an explanatory overview of what you can use Linux for in the learning process and also in your day-to-day work with analysis and other operations you might need to perform. And then over the next 6 weeks, every week, there will be a new video posted to CWNP TV that will demonstrate the main concepts we're talking about here today. So instead of just leaving you on your own to do a lab, you will have videos that you can walk along with in order to go through the process. Let's jump into why Linux. That's the first thing I want to talk about. Why use Linux in your lab? I would suggest that one of the main reasons that you want to use Linux in your lab is because it's open source. And what that means is there are a lot of things available to you for building out a lab with little to no cost, other than, of course, you obviously need hardware. And you might not even need that. If you already have some USB Wi-Fi adapters lying around that are compatible with Linux, and you have a Windows computer or a Mac computer that is powerful enough to run a Linux virtual machine, then technically speaking, you could actually boot up a virtual machine, pass through the USB adapter to it, and do pretty much everything we're going to talk about here today, and that we'll be demoing in individual demos over the next 6 weeks. So the fact that it's open source means you get a low-cost budget lab environment. And you can also accomplish doing some things that might normally require specialty hardware to play around with those concepts. So for example, there are ways, and I'm not going to get into the complexity of it here today, but you can search for it on the internet and find solutions. There are ways that you can run OpenWRT in a virtual machine using a USB adapter and get full access to the vast majority of features that are commonly there in even enterprise access points, so that you can work with those and play around with them and get a feel for them, even if you don't have the budget to get an enterprise device into your home lab. So open source is really cool. Also, Linux gives you low-level wireless adapter access. Now, what I mean by that is twofold. First of all, it lets you very easily capture true Wi-Fi frames. Mac OS does that for you as well. And Windows, you got to have the right driver, right? So you got to have the right driver, the right adapter on Windows to accomplish the same level. It's better today than it was 7, 8 years ago, but it's still not as open as Linux in this area. The other way that it gives you low-level access is it reveals a lot more detail to you about your Wi-Fi adapter. More information about the radio chipset that it's using, the PHYs that it supports, the transmit power that it's working at. A lot of things are made available to you, accessing the internal parameters of the device driver effectively for that device so that you can see that information, which is not easily available on Windows for sure. Another reason, it's open source. Okay, there are ready-made distros. So what I mean by that is there are Linux distros that you can use that already have a lot of tools in them that are useful for the Wi-Fi engineer. And it's open source. And then it has a small hardware footprint. So it means you can run it on something like a Raspberry Pi, and you don't have to worry about having a beast of a computer in order to have a lab where you're testing and learning about Wi-Fi. And of course, you know, I have to add this, it's open source. So a lot of reasons to use Linux. Now, when it comes to learning with Linux and getting in there and doing hands-on work, there are a few things I would recommend you do. And by the way, these are effectively the things that we'll be releasing demo videos for. You install and configure network adapters. And so you want to be able to understand how to configure a network adapter and interface. Capture packets and analyze them. Implement an open source access point. Monitor distributed Wi-Fi devices. Audit security settings. And evaluate performance. Now, why are these things I would recommend that you want to actually do in your learning process, because these are things you'll need to do on the job when you work with Wi-Fi. And so it's very important to know how to do these. Now I'm going to show you tools and solutions that you can use for these today. I'm going to let you see some of the resources that are available as we take a tour. But again, we'll have 6 different videos focused on each of these 6 things, releasing over the next 6 weeks, 1 per week, on CWNP TV. So if you're not subscribed, make sure you subscribe to the YouTube channel, and you'll be able to get notifications so that you know when the videos are released. So we want to take a tour of what tools are available to us in this Linux world for doing these kinds of things. Now, the first thing that you need to do is you need to pick the operating system, right? It's not like Windows. There's only one Windows. Well, okay, there's not. There's Windows Server, there's Windows Home, there's Windows Enterprise. You know, I get it. They're Windows Professional, etc. So there is that, but it's still Windows. So there's only one Windows. There are different versions, but only one. There's really only one Mac OS, different versions, but only one. But with Linux, there are a lot of different distributions. Now, Debian, or Debian, some people call it, is one of the most widely used Linux distributions out there, either directly or because of other distributions that are built on top of it. And so this, you can just run Debian itself directly and use it as your distro. And you can also look around for distros based on Debian that might meet your needs. So for example, they might, in other words, give you a small footprint. You know, one of the things you're going to find when you work with Linux is you're going to kind of go back to the MS-DOS days, where you're going to do a lot of things that you do at the CLI. You're going to find yourself in the shell, which is the CLI for Linux, right? So you're going to find yourself working with that. And particularly when you want that small footprint distribution installed, you're probably not going to be worried about, you know, am I using KDE or GNOME or some other GUI? You're going to be doing a lot of what you do at the shell. And that's actually one of the benefits, is that you can do pretty much everything at the shell. Now, can you do everything at the Windows command line? Well, you can do about 99% as far as operating system functions. You can do about 99% of them at either the command prompt or in PowerShell, if you know where to go to find it, and it can be really hard sometimes, but you can generally do it. But Linux is more of a shell-first world. That's not to say there aren't some things that are GUI and fully GUI. I mean, obviously you can run things like LibreOffice and have a GUI interface for a word processor or a spreadsheet, whatever. But as far as the operating system itself, there's not hardly anything you can do in a GUI other than maybe manage the GUI settings for the shell, the GUI shell you're running. There's not hardly anything you would do as far as configuring basic operating system parameters and so forth that you can't also do in the shell. And some things you can only do in the shell. So you're going to get very used to that. And when I say small footprint, I mean that the operating system does 2 things. One, it minimizes the space consumed in storage on your hard drive, and it minimizes the RAM consumed to run. And that's what allows it to be a good distro for things like a Raspberry Pi. So you don't consume a lot of your available RAM, usually 2, 4, maybe 8 gigabytes on a device like that of RAM, and you leave that available for the other things you want to run. Now, one of the most widely used distros based on Debian is Ubuntu, and Ubuntu is a very popular operating system for what you might call moderate Linux users. So in other words, they're not really there for the tech stuff. They just want an operating system other than Windows to run on their PC, and Ubuntu is where a lot of them end up. So that's a very popular distro. And then Linux Mint is also obviously very popular. This is more used by the more technically inclined Linux folks than Ubuntu, but Ubuntu is used by them as well, to be clear. I don't want to mislead there. Ubuntu is both moderate and up, whereas Linux Mint is mostly more technically inclined folks that use it. And then there are some that, they try to mimic Windows. So they try to make the Linux interface look as much like Windows as possible. If you're brand new to working with Linux and you want something like that, do a search for Linux distros that look like Windows. You'll find there are several of them out there. So there are definitely options for that if you want something that feels more comfortable early on. But being that you're in the tech space, or you wouldn't be on this webinar most likely, I discourage that. I would encourage you to go right for the technical hard stuff and just jump in on the more complicated Linux, because you're going to need to understand it well to really use it effectively as a lab type tool. Additionally, keep in mind that tons of network appliances out there just run embedded Linux. That's what their operating system is. So when you SSH into them, you're dropped into a Linux shell command line environment. And so when you know Linux, you get the benefit of being able to work with that. I mentioned OpenWRT. It's a common open source firmware that you can use on some wireless routers, home routers, for example, so that you can get more capabilities. Again, if you SSH into that, you're accessing a Linux shell. And then you use commands that you learn when working with Linux to install extra services and software onto that access point and configure it and so forth. So I would encourage you to just jump right in and just learn it and understand it. Then you have some of your distros that are there for certain purposes. So there are distros that are just for monitoring or for, enterprise configuration management and things like that. And they just come with various open source tools built in. The most popular, without question in the world, customized distribution of Linux for a specific purpose is Kali Linux. Kali Linux is a security pen testing distribution, but it's great for use when you want to learn Wi-Fi. The reason being is it already has a lot of the tools pre-installed, and all you have to do is have a compatible USB adapter that you plug into it or pass through to it if you're running Kali Linux in a virtual machine. And then you can actually just immediately start running things like Kismet and Wireshark and Aircrack and all the rest, because they're just already in there. And so it's a really good operating system to use. And then, of course, there are specialty hardware devices out there that many people have developed, even in our community, like the WLAN Pi, which looks like someone just mentioned in the chat, that is, really running Linux as well. And so you want to know how they did that? Get into Linux, start working with it, and you can learn that information. Now, I left for last when it comes to distros, Red Hat Linux, not because it's not popular, but because hobbyists and people in labs don't run it as much. But it is one of the most widely used Linux distributions for servers in organizations, and it's used a lot for web servers as well because of the support that's behind it and so forth that you can get. And obviously you can run Red Hat Enterprise Linux. The reason I'm here at the Red Hat developer section is because the way you run Enterprise Linux as a developer, and therefore for your lab, is you create an account with Red Hat, then you join the developer network, then you can use Red Hat Enterprise Linux full version for your development procedures. And in other words, in your case, for your lab environment. So that's another excellent distribution. Now let's get into the tools that you're going to want to bring into your lab environment so you have them available for you. One you might already be familiar with because it's available on Windows, even if you're not a Linux user, is Nmap. So Nmap is a great tool to kind of get started on understanding command line tools. Yes, there's a GUI for it, but don't use it. Use the command line. Now, I'm not telling you don't use the GUI ever in your day-to-day job. I'm saying use the command line so you can get used to using the command line. So Nmap is a great free tool. It's not open source per se, but it's a free tool. And an interesting thing too, great learning experience you can go through. I haven't looked to see what the newest LLMs do today, but about a year and a half ago or so, I went into one of the LLMs, I can't even remember which one it was, and I said, write me an Nmap clone in Python. The only thing I want you to do is accept an IP address and subnet mask from the command line as parameters, and then scan all of the IP addresses in the block based on the IP address and the subnet mask, and find any devices that are there and responding, and look for open ports for port 1 through 100. And that's all I did. Just pretty simple. But here was the catch. I said, you must write it purely in Python with no external libraries. Now, it did a pretty good job, and it actually worked what it ran. Did it give me everything that I actually wanted out of it? No, not necessarily, but it did work. I would imagine today, if you tried it, it would do even better. But here's the point. Here's why it's a good learning experience. You can look through that code, see what it's doing, and really understand the internal workings of a tool like this. And then if you go further and you say, like nowadays with Gemini and the Canvas, or Claude Code, or whatever, if you're into actual coding, you might be actually using some of the tools that do that for you, like add-ons for Visual Studio Code and stuff like that. But you can just go into any of the major LLMs now and ask it to do it. But then once you get it, you can say, now add the ability to do 3 different types of TCP scans, and then give it the types you want it to do. And then look at the code that it generates so you can understand how those scans actually work. It just gives you a deeper understanding of the process. Because when you look at the code, you're going back to something I talked about last year, and I've been talking about now for years, and that's algorithmic learning. Learning how things work by writing your own algorithms. But what we're doing now is we're taking advantage of the LLM, telling it to write Python code that does it. And you might say, well, I don't understand Python code. Okay, well, then tell it to write pseudocode that defines the algorithm for how it would work. And then just look at that step by step and looping processes and anything that's in there, and you can understand that process much better that way. It's a phenomenal learning process. Wasn't really planned to be part of this to talk about that, but that's okay. So Nmap is the first tool that you want to get. Another tool, lesser known to people, and it hasn't been updated now in a few years. There was an update to it 1 or 2 years ago, but not a lot of updates recently. But it's called Wavemon, and it is still useful, does still work on Linux. And what it does is it gives you these kinds of stats really easily. Now, you can get these different stats using different tools like IWFi and IWconfig and other tools if you have them in your Linux distro. But this tool just kind of aggregates it all together for you and shows you the information. So you can see statistics for transmissions and receptions. You can see the mode the device is in, how long it's been connected, the frequency and channel that it's on, beacons that it has received, the average signal strength, the transmit power it's using. You can see the network that it's connected to, the IP address that it's received, and so forth. So it's just a nice tool to give you some quick overview information about your Wi-Fi interface. And again, I find a lot of people don't know about the tool. It is an open source tool. You do need to compile it. So it takes some extra learning to use it, but that's one of the reasons why I encourage you to do it. If you've never done it before, if you've never had to download and then compile the program to be able to run it, this is a great first one to do it with, because it's actually giving you a useful tool for Wi-Fi, and it allows you to go through the process of doing that download and compilation. Another tool that you're going to find very useful is Kismet. Been around a long time. They keep on enhancing it. And what Kismet does is it gives you basically an Insider or a Wi-Fi Explorer Pro type of tool. So it finds the networks and gets information about them, also gathers information about client devices that it's seeing on the channel and so forth. So it's gathering a lot of information for you. But here's one of the cool things about Kismet. So the way it works is it sets up a server. And then this GUI that you're looking at, if you're looking at this, and by the way, this is an ASCII-based GUI, or there is at least an ASCII-based GUI. So you're actually still in the shell while you can look at the information. It's kind of like some of you are as old and bald as me. It's kind of like the old VB for DOS. I don't know if any of you have ever played with that, but Visual Basic for DOS was a short-lived thing. It came right at the end of the lifespan of MS-DOS before Windows 95 really killed it all. And the Visual Basic for DOS allowed you to build GUI interfaces that worked in DOS. But if you ever worked with the text editor in DOS, then you know what they looked like. So what that looked like is what your Visual Basic for DOS applications look like. So something similar to that, Kismet gives you. And so there are really cool capabilities with it just right on your local machine. But the reason I like it is when you go down here to the API section, notice REST-like API. So basically, Kismet has an embedded web server. And the way REST works is you call an API, and usually, anyway, in the vast majority of cases, it sends back JSON data, JavaScript object notation, which is just a standardized format for the data structure. And the cool thing is then, you can look at these REST API endpoints and gather data. And what can you get? Well, take a look. You can look at devices. So if we go into devices, we can see our devices. We can see device by key, device by MAC address, multiple devices by MAC address, and on the list goes. So you can see your devices. You can look at the packet capture. So you don't necessarily have to start the packet capture. It's just waiting for you there. So you can go in and grab it anytime. It's in the PCAP-NG format. So whatever the IP address of your Kismet server is, you just go to /pcap/all_pcaps.pcapng. Or you can do it based on a particular data source, a particular device. It's just waiting for you to go and start grabbing it. You can grab information about channels that are in use. You can look at just alerts that have been triggered. You can see, for example, GPS information. If there's a GPS element added to Kismet, most people don't have that in there when they're using it, but if you do, you can. The point is, all of this is simply right there waiting for you. So here's an advantage for your learning processes as you move forward in the network administration and management world. Automation is going to become more and more important all the time. It's important right now. It's going to become more and more important all the time. And REST APIs are one of the key things we use in that world. So this is a great thing to work with in your lab to get an understanding for REST APIs. Take it a step further. Don't just use curl, C-U-R-L, curl at the command line, the shell, to retrieve this data and then look at the JSON. Go into Python, write a script that retrieves it, processes it, outputs it the way you want it to be outputted, and so forth. Go through the process so that you can actually understand how these things are working under the hood. The next thing you have is TCP dump. So TCP dump, widely used so that right from the shell, you can just start capturing packets. You can either dump them literally to the screen, or you can dump them to a capture file. And then, of course, you can analyze them. What can you use to analyze them? You can use Wireshark. Runs on Linux, runs on Windows. You can capture on Linux and then do your analysis on Windows or in the Mac GUI if you want. The point is, Wireshark is your tool for doing the analysis. But there is also, with Wireshark, and a lot of people don't know, there's T-Shark, which is a command line interface. Now, this is on Windows and Mac and Linux. And what it does is it gives you access to Wireshark, more advanced like functionality from the shell interface, so that you don't have to run the GUI in order to do your capture. So very useful to know that that tool exists as well. Then you have Aircrack NG. This has been with us for a very long time. I'm not going to say how long, because it just makes me feel old when I think about how long this has been around. So it has been around a long time, but they do continue to improve it and enhance it when it's needed. And basically what this suite of tools does is it gives you the ability to easily, you can do it other ways with Linux commands, but very easily put your adapters into monitor mode, begin to scan for SSIDs, but it also has cracking tools in it so that you can go through the process of cracking WEP, WPA, etc. Just a lot of things that you can do with the overall tool set. And in a lab environment where you're focused on wireless, you're going to want to have Aircrack NG installed. And by the way, all of these, Kismet, TCP dump, Wireshark, Aircrack NG, they're all installed on Kali Linux by default. Then you have another interesting tool called BetterCap. BetterCap is a better capture tool. Basically, it is a capture tool written in Go. So because it's written in Go, anywhere you can compile and use Go utilities, you can utilize it. It has the ability to work with Wi-Fi, Bluetooth Low Energy, and other things, but it also goes beyond just Wi-Fi or layer 1, layer 2, and it does more advanced things, even to the level you see here. They're highlighting the fact that it does the ability to scan and do mouse jacking attacks over the air. Yes, that's right, mouse jacking, if it happens to be a Bluetooth mouse. So at any rate, this is one I just want you to look at. Not going to tell you need to use it, but here's the thing. When you're learning Linux, it's a really good idea to not say, okay, I'm going to use TCP dump and Wireshark, and that's it. Take a look at the other tools that are available to you and see what they might offer. Because as you're looking at those tools, you're advancing your learning in how packet capture works and what kind of things you can do with packet capture and the difference as to what they look like when you've captured Wi-Fi versus Bluetooth and so forth. So a very useful tool to get your hands on as well. The next must for your learning is HostAPD. HostAPD gives you the ability to basically implement an access point. So you take your Wi-Fi adapter plugged into your Linux system, again, either directly in hardware if the Linux is running on the hardware, or pass through to your VM if you're running it in a virtual machine, and you simply implement an access point. Now, with HostAPD, normally when you implement the access point, you're going to configure all of this through configuration files or conf files. And it's text files that you go in and configure and so forth. And I recommend for your first setup, do that. Go in, configure it manually, go through the difficult, painful process of making it work, so that you get that learning experience, right? But once you've done that, then there's a great tool called RaspAP, which works on top of HostAP and gives you a GUI interface that you can use to configure your AP. And you can see the features it gives you. There's an overall dashboard, but then you can work with hotspot settings, implement a DHCP server, networking settings, Wi-Fi clients, firewall settings, VPN settings, data usage, monitoring about your system. There's a REST API. This is one of the reasons I like it. It gives you basically a REST API to HostAPD. And so what that means is that you can, again, go through this process of learning about REST APIs and seeing how you can work with it for automation and remote monitoring and even configuration and things like that. So RaspAP is a great way to piggyback on top of HostAPD and get those extra capabilities that make it feel more like a real access point. Now, The next things I'm going to talk about go beyond an individual system. So the first one I want to talk to you about is Prometheus. Prometheus, I find it's not talked about as much in the networking space as some other monitoring and automation tools, but I think that's because of the primary focus of the tool. When you start reading about it and looking at it, what you see is it's about application monitoring and analysis. And so it's really focused on monitoring different applications and some operating system stuff as well. But it goes far beyond that. So it is a monitoring solution, but the way it works is really intriguing. So let's jump into the docs here. And again, I'm going to, in one of the demo videos in the next 6 weeks, I've got one for you that goes through the whole process of setting this up. Not only setting it up, but creating a custom Prometheus client, which interestingly enough is a server, but we'll get to that in a second. Setting up a custom Prometheus client that you can run on a computer to gather Wi-Fi information for Prometheus. But at any rate, so it's an open source systems monitoring and alerting toolkit. It's been around since 2012, so it's not a new kid on the block. And the interesting thing about how it works is you've got a Prometheus server, and the Prometheus server is the thing that collects all of your metrics for monitoring purposes. And it has some built-in things within it. So if you go here to visualization, there's an expression browser, but it's very limited. It's not really that capable. What you're going to do is you're going to usually integrate Prometheus with Grafana. And again, in the demo video, that's all in there. So Grafana gives you visualization. So I'll just pull this up real quick so you can see that. So you can see here the visualization. Grafana is not a Prometheus tool. It's another open source tool that you use with Prometheus, okay? Prometheus does the work of gathering the metrics and bringing it in a standardized and consistent format. And once you have that in that standardized and consistent format, you can use Grafana using Prometheus as the data source to generate dashboards, okay? So that's basically what we're looking at here. Now, one of the things that you do down here under instrumenting. So instrumenting is the fancy term for telemetry collection, collecting the metrics from your instruments, the telemetry data from your instruments. It comes out of the OT space and operations technology. And so the thing you're going to need is a client to do this work for you. But what your client is going to be is a web server. Okay, so this is the interesting thing. So notice it says when Prometheus scrapes your instance's HTTP endpoint, the client library sends the current state of all tracked metrics to the server. So in other words, the way it works is the agent that's running on the end device is first of all doing internal logic to gather whatever the metrics are. And then it's also at the same time running a web server, a very minimal web server, but it's running a web server on some port like, 9090 or whatever. And Prometheus is configured to know that that client is out there and to go and scrape it however often it's configured to do it. Once a minute, once every 5, once every 10, once every hour, whatever you want. And so it goes out and scrapes for that, but it's grabbing it from the quote unquote client that is actually an HTTP server. Okay. So that's the thing to keep in mind about how the architecture works. The interesting thing is they do have Python libraries for this already. So when we go in here, you can see that this is the Prometheus Python client, and it's basically a client. Then when you look at the code, there's a file here called exposition.py. And notice that some of the things this needs, it's saying, for example, from http.server, import request handler, and so forth. So it's actually using standard Python libraries to implement a HTTP server that's on the client. Now, this is something that you need to consider. It's great for lab. Security becomes an issue if you implement this in the real world, right? If you're going to have, 500 laptops and you're going to put a Python-based Prometheus client on all 500 laptops so that you got great Wi-Fi metrics coming in using a custom client that you've built to your central Prometheus and then to your Grafana reporting, that's all fine and good. But obviously, you need someone involved in that process that's going to make sure that it's implemented in a secure manner. That, for example, there's something in the client that detects when it's not on your enterprise network and it's not running, because you don't want an HTTP server running, even if you've secured it and required authentication and all that. You don't really want that running when they're roaming around the world and connecting to Wi-Fi at hotspots at airports and such. So you've got to think through that process, but this is the way Prometheus is going to work. So now Prometheus then, again, that's the server, scans the Prometheus clients, gets the metrics. And, what metrics are you getting? Well, for example, you can use PowerShell or NetSH on a Windows machine to gather metrics. I don't recommend doing that. I recommend, if you're going to gather metrics on Windows, to do it through the Wi-Fi subsystem APIs. And that can be done in Python. You can write, C++ code to do it and so forth. And there are client libraries in C++ that already give you the building blocks for Prometheus part. Then you just have to have the C++ code to do the rest. The point is, the reason I don't recommend doing it in Python for a Prometheus client, if you can avoid it, is because it's going to be a text file sitting there on their hard drive. And if someone gets local access to it, they could simply modify that text file and, have it do some pretty bad things, right? So I would recommend that it be a compiled solution if you have the people on staff to do that, or you have the skills to do that. That way you have that extra protection. And probably if you're going to roll this out, again, to laptops and other Wi-Fi devices to gather these kind of metrics, you're going to want to do it in C++ or something like it, so that you can compile it to consume less resources on that endpoint. That's the effective end result of that. Okay. And then another one that I want to mention to you is the Elastic, the ELK stack. It's often named because it uses Elasticsearch, Logstash, and Kibana is the traditional model for how to do that. And what it is about is giving you aggregation of your logs, Elasticsearch for REST API-based search and analytics, and then Kibana is giving you your dashboards in this case. So this is another one, same deal though, you got to get the data from somewhere. But if you want to build a visualization dashboard, go through that process, this is another tool that you might use for that. And the final thing I want to encourage you to look into is Canonical's OpenStack. This is something I'd encourage you to look into because the cloud is wildly important today. And I don't just mean AWS and the fact that some Wi-Fi vendors use cloud technologies. I don't just mean that. I mean, even on your enterprise network, the cloud is really important. And more companies are implementing enterprise cloud on premises. So they're building out their own cloud data center and implementing it. And OpenStack is an open source cloud management platform. So you can use it in your lab. And I'm going to close this down because it keeps beeping through my computer, through their notification. But OpenStack is an open source cloud management platform that is layered over top of a virtualization solution. You can either use one of the open source ones that it can pre-install for you, or you can use, ESX, Hyper-V, what have you. And it also has support for containers. And so the point is that you can build your lab out as a local self-deployed cloud. And you might think at first, man, Tom, what kind of budget do I need to do that? Well, ideally you've got a couple $100,000 so you can have a lot of fun, but let's say you don't. Well, all of your real physical nodes on your cloud can be used devices. So for example, you can buy Dell mini PCs that run at multi-gigahertz and have 4 gigabytes of RAM and a few hundred gigabytes of storage space. And you can get those for $20, $30 a piece used. Get 15 or 20 of those and just use those to build your cloud. You can use Raspberry Pis if you want to, which will consume less power and give you similar processing capabilities. Might not be quite as fast on the CPU front, but similar. So there are a lot of ways that you can, with less than a few $100s, get yourself a multi-node lab that you can deploy OpenStack over and have your own little cloud that you build, and then play around with how you deploy virtual machines, containers, etc., within that cloud environment. And so I really do recommend taking a look at OpenStack, because I think it's going to be more and more popular to see enterprise on-premises cloud technologies in the future. I don't know if you've noticed this, but there's actually been a pretty significant trend over the last 3 years of people going back to on-premises and away from some of the major cloud providers. Not that they're leaving them entirely, but they're taking significant portions of the workload and bringing it back on-premises. Because what's happened is, over the years, as they've used the cloud solutions, they've learned that some things are just cheaper to do on-premises in the end than they are to do in the cloud. And so we're seeing a lot of that happen. And that's something that's probably going to continue. All right. So let's summarize with a reminder that over the next 6 weeks, if you're watching a recording of this on CWNP TV, if it's after the end of October 2025, then these recordings will already be on CWNP TV. But there will be a recording for each of these 6 things that we've talked about. So one for using Linux to install and configure network adapters, but we're not just going to install and configure it. I'm going to show you the different tools like IW and others as well that can be useful in finding out low-level information about your devices. Then there'll be another video on capturing packets and analyzing them. We'll use TCP dump, we'll use T-Shark, we will use BetterCap. There will be a video on implementing an open source AP. We'll use host APD directly, managing it through conf files. And then we'll take a look at the GUI option. There'll be a video on monitoring distributed Wi-Fi devices. So we're going to go through the process of setting up Prometheus, but we're also going to build a custom Prometheus client that gathers the Wi-Fi metrics we want and provides them to Prometheus, and then see how those get migrated into Grafana. Then we'll talk about auditing security settings. We'll take a look at doing this with things like Kismet and other tools that are useful for that process within the more centralized realm. So we're going to take our Prometheus type model to the next level and say, okay, so we've got Grafana. What else can Grafana pull from as a data source? So we'll see how we can capture security information and get that into Grafana. And then finally, we'll look at how we can evaluate performance. We'll look at some different testing methods that we can use in that video with the Linux environment to test the performance of Wi-Fi under different conditions, different channel bandwidths, different types of data communication, and things like that. And so 6 really great demos, each between 30 and 60 minutes on their own, coming out over the next 6 weeks. Why? Because we love you. It's really that simple. We care about you, and we want to make sure you have the tools to succeed. And hey, I thought it would be fun.